Hello students, welcome back. We went through some application problems on normal distribution, and I think it's going to be better to have some more application problems. More application problems of same kind. And I exhausted problems here in this notebook set. So let's go to some example problems from my 1680 class. Okay, here we go. A radar unit is used to measure the speed of automobiles on the expressway during the rush hour traffic. The speed of individual automobiles are assumed to be normally distributed with a mean of 62 miles per hour. Okay, all right, never mind about that. If the standard deviation is about 4.95 miles per hour, what is the proportion of the cars that are traveling in 70 miles per hour or less? So I hope you can see that this is a straight ahead probability computation. Also, 70 miles per hour or less, so the shading is to the left. Let's go ahead and do this. Okay, here we go. Oh, bad drawing. Okay, let me try again. Not much better. Okay, all right, and that's 62, mean of 62, and then 70 is going to be, of course, here, and 70 or less, so shading is to the left. All right, does it make sense? And then we want to find out the z-score according to this. So x minus mu over sigma. So that's gonna be 70 minus 62 over what sigma? Is everybody happy with this z-score computation, x minus mu over sigma? And then punch your calculator, you're going to get something. And then that's going to go to your normal table. Make sense? Okay, let's go back to the notebook. Okay. Oh, this notebook is for 1680 students, so I broke down far more in detail, and I'm being far more kind to students, so to speak, in terms of how to set these up. In 3000 level, I would like to give a little bit more freedom to students, but okay, this notebook came from 1680, so let's follow that particular model. All right. So this is what I encourage to elementary level students, how to draw a picture, outline, center, end, and then shade. In 3000 level, I give a little bit more freedom to students, but well, you can still follow the same way, 1680 method, and then do well. So here we go. Outline, okay, it's there, and then center. And this is 1680 levels, so instead of using mean or expected value or those kind of formidable mathematical name, I end up using the center so that they can understand better. And at end is my x value, and then shade to the left or right. You see, 70 miles or less, so shade to the left. So there goes your picture. All right. Based upon this picture, you have to draw z-score and z-table. Z-score x minus mu over sigma, or, oh yeah, in this picture, end minus center over SD. This is quite useful, end minus center over SD. After drawing the picture, of course, I'm going to give a little bit more freedom to 3680 students, and also I'd like you to know what it means by mu what it means by sigma, those kind of things. So this may be a bit too much of an elementary way, but it works pretty well for 1680 level. N minus center over SD after drawing the picture. And that is 70 minus 62 over 4.95. Calculate, you get the z-score. All right. So what is your probability? Just by looking up the z-score up to this, 1.6, 616, 1.62 is going to be better. So look up the z table, and 1.62, so it's down here. 1.6, what do you have? 0.9474? 0.9474. Yeah, that's the probability. Here I use Mathematica to calculate, so I got a little bit better picture. I mean, a little bit better number, 0.94697. And then, of course, eventually we end up with about 95%. And then the justification is, of course, there, x minus mu over sigma, and something we have been doing in 3000 level. Now let's go backwards. Find the 25th percentile using the standard deviation of 1.1. So 4.95 is the standard deviation, and 25th percentile, what is this? So here we go. Here is the x-axis, normal picture, and then you have 62, and 25th percentile must be somewhere here. And this shading here is 25%, so 0.25. And basically this is what you're looking for. So the strategy is to look for z-score associated to 25% from the z table, and then get z equals to x minus mu over sigma, where mu is 62, and sigma is 4.95, and x, of course, is the value you're looking for, and z value you found out from the z table, or if you prefer, n minus center or SD. Either way, it'll work out. So that's the strategy. Okay, there you go. Draw a picture. Outline, center, end, and shade. I don't know end, so X, I'm going to find out. And this is 25th percentile, so 25%. And look up 25% from the Z table. Let's see. Here we go, 25%. Where is it? From the first page, closest to 25%, 0.25. Right here, 0.67 or 0.68, somewhere in the middle, 0.675. Here I use a little bit more accurate figure, 0.67449. But if you look up the table, you're going to get 0.675, approximately speaking. So use that to figure out x and solve that equation. This is what you're going to get, approximately speaking. So the 25th percentile is about 59 miles per hour. Okay, I think that was easy. Now the next problem. If the 3% of the automobiles travel faster than 72 miles per hour, what is the standard deviation? And this used to cause a lot of trouble to 1680 students, but not here. I do not expect any trouble here for 3680 students. Standard deviation is not given there. Previously 4.95, but no more. Now I want to find out standard deviation. So here we go. Okay, let's go ahead with the picture. Okay, all right. This time the picture came out relatively well, 62. And then, let's see, where's 72? And then 3% of the cars are driving faster than 72 miles per hour. So this probability here is 3%. Does it make sense? Therefore, this part here, that's 97%. So you have to look up z-score for 97 percentile. Once you do that, what do you expect? So z-score for that, okay, we got that. And end minus center over standard deviation is that z-score you find out. From here, what is your sigma? Well, basically that's the strategy, isn't it? Make sense? 72 or higher, 3%, so draw the picture. So the other is 97%. So that's going to give you the z-score of 97th percentile. From here, you can find out sigma because x minus mu over sigma is your z-score. Make sense? Here we go, 3% here, 97% here, and you're looking for sigma, standard deviation. So x minus mu over sigma, you can solve for sigma, all right? And then the z-score you look up about 97th percentile has turned out to be 1.88. Let's see, you can check. Let's see. Second page, where is 97th percentile? Closest to 97%. 9713. 9699. Okay, that's the closest. 1.88. Yes, 1.88. So 1.88 is your z-score. From here, you can find a sigma. It's an easy equation to solve. If you do that, you're going to get sigma equals to, well, this. 5.3169, or approximately speaking 5.317, or even 5.32 miles per hour. Or even 5.3 miles per hour. I didn't specify the decimal digit. Okay, so much for problem 3. And then problems 4 and 5 are actually continuation of problem 3. Find the proportion of the cars that are traveling faster than 50 miles per hour using the standard deviation of 1.3. All right? Do not use 4.95 anymore, because that applies to problems 1 and 2. For 1.4, you have to use the previous result of, I forgot already. Yeah, 5.32. So no more 4.95. Sigma is 5.32. Same here. Using 5.32, you have to answer 95th percentile. I'm going to leave 1.4 and 1.5, these two problems as exercise set for you. Oh, wait a minute. These problems came from 1680 problems, so you don't have these problems. Okay, I better do these. But I guess I can do it quickly. Draw a picture, all right, 62 and 55 or higher. And then calculate the z-score, x minus mu over sigma, where sigma value is 5.32. So here. n minus center over SD, or x minus mu over sigma, and standard deviation is 5.317, as you found out in part 3. Calculated, you get negative 1.31 or negative 1.32 approximately speaking. Look up the z-table and get your answer. And you get 0.093 something, this one. And then you want the other part, so subtract from 1, you get about 90% or so, 90.6%. Now, how about 95th percentile? This is a backward problem. You have to look up the table and find out z-scores for 95th percentile. Here, there, 95th percentile. Closest to 95 here, 9495, 9505. So 1.64 versus 1.65. So 1.645, approximately speaking. So this is what we want, 95%. Look up the z-table as we did. You get something close to 1.645. Somewhere in between 1.64 and 1.65, 1.645. Here I'm using a little bit more accurate figure, 1.64485, because I use statistical calculation through Mathematica. 1.645 will do in reality, and then you can use this, you can solve this equation through x. If you do it right, you're going to get about 70.75, something like that. That is the 95th percentile. Okay, so much for this problem set.